Hello students, today we are going to learn investment analysis part 2 of unit number 6 of the operations research course TYB Tech Mechanical Engineering. Myself Dr. Preetham S. Kalos, Associate Professor, School of Mechanical Engineering, MIT, Academy of Engineering, Alandi, Pune. In previous two sessions, we have learned some of the methods of investment analysis. The methods of investment analysis are broadly classified into two models, deterministic models and probabilistic models. As a part of the curriculum, we need to learn only the deterministic models. In previous two sessions, we have learned break-even analysis, payback period method, and net present value method. As a part of today's lecture, we are expected to learn internal rate of return method. Both net present value method and internal rate of return method both are discounted cash flow methods, that is, they consider the time value of the money. I have already explained the concept of the time value of money. So now I will directly switch over to the slide related to internal rate of return method. Internal rate of return method. The internal rate of return is the rate that equals the present value of the cash inflows with the present value of the cash outflows of an investment. Thus, it is the rate at which the net present value of the investment is zero. It can be determined from the following equation. C is equal to A1 upon 1 plus R plus A2 upon 1 plus R bracket square plus an upon 1 plus r to the power n, where a1, a2, an, these are the annual cash inflows at the end of first year, at the end of second year, and at the end of nth year. R, it is the rate of return. Now we want to find out the R such that the net present value is 0. The difference in IRR method, internal rate of return method, and NPV, net present value method is, in net present value method, we try to calculate the net present value of the proposals assuming the rate of interest or say cost of capital. But here, in case of internal rate of return method, we want to calculate the value of R such that net present value is 0. What are the merits and demerits? Merits: like the NPV method, it considers the time value of money. It considers cash flows over the entire life of the project. It has psychological appeal to the users. Demerits: it is difficult to understand and use in practice. It may yield results inconsistent with the NPV method if the projects differ in their expected lives or cash outlays or timing of the cash flows. It may not give unique answers in all situations. Let us try to solve one example related to internal rate of return method. Internal rate of return method. A project costs rupees 32,400 and is expected to generate cash flows of rupees 16,000, 14,000 and 12,000 over its life of 3 years. Calculate the internal rate of return of the project. See, as a part of this numerical, they are saying that the project costs 32,400. That means you are investing into the project amount of rupees 32,400. Means 32,400 is going out from your pocket, so it is the cash outlay. Now what are the cash inflows? Cash inflows are rupees 16,000, 14,000 and 12,000 at the end of first year, at the end of second year and at the end of third year. And we want to find out the internal rate of return, that is the value of R such that NPV is equal to 0. Now we will try to assume initially 20% as a first trial, 20% rate of return as a first trial. So based on the 20%, we can calculate the discount factor. We know how to calculate discount factor. It is 1 upon 1 plus 0.2, that is 1 upon 1.2 to the power 1 because it is at the end of first year. Second, 1 upon 1.2 to the power 2, 1 upon 1.2 to the power 3. This is how you can find out the discounting factor. Now how to find out the present value of all the cash inflows? Present value can be calculated by multiplying the cash inflows with the discounting factor. So 16,000 multiplied by 0.833 is equal to 13,328 and so on. So this is the total present value of the cash inflows. Cash outlay is 32,400. So we are subtracting this cash outlay from the total present value of the cash inflows, and hence we can obtain the net present value. This is minus 2,408. See, we want to find out rate of return R such that net present value is 0. Means we need to approach towards 0. Okay, on arithmetic scale, we need to consider now next rate of return such that this negative value will try to approach to 0. So we can take 18% as the next trial, calculate discounting factor, okay, calculate present value and calculate net present value. Net present value is minus 1,488, which is less than minus 2,408. Okay, means we are approaching towards 0. Okay, now next present value. Next present values can be calculated considering a discounting factor of 16%. Calculate the discounting factor considering rate of interest equal to 16%. Okay, multiply the cash inflows with this discounting factor, that is 16,000 multiplied by 0.862. Calculate present value. So for 16% as the discounting factor, net present value comes out to be minus 514. Means slowly we are iterating towards 0. Next, considering 14% as the discounting factor, we can calculate the present values and then the net present value. Net present value for this comes out to be 498, which is positive. For 16%, NPV is negative. For 14%, it is positive. That means the internal rate of return must lie between 16 and 40%. We don't know, it may be 14.5 or 15.8, 15.5, etc. So we are just trying for another trial of 15%, okay, to find out whether the internal rate of return lies between 15 and 14 or 15 and 16, okay, or it is exactly at 15%. So calculate the discounting factor considering interest rate as 15%, that is 1 upon 1.5 to the power 1, 1 upon 1.5 to the power 2 and 1 upon 1.5 to the power 3. Then multiply this discounting factor with the cash inflows. You can obtain the NPV, calculate the present value of all the cash inflows, subtract the cash outlay, that is 32,400 initial investment made at the start of the project, then NPV is equal to 0. Since NPV is 0, internal rate of return is 15%. I can try to show you these calculations once again using the Excel sheet. Okay, so considering 15% as the discounting factor, so 1 upon 1 upon 1 plus 0.15, that is 1 upon 1.15, okay, to the power of 1. Here discounting factor for the second year will be 1 upon 1 plus 0.15 to the power 2. This is 1 upon 1.0.15 to the power 3. Okay. Then calculate the present values. Present value is this discounting factor multiplied by cash inflow. Make the summation, subtract the cash outlay. Okay. This is how you can obtain the present value. Okay. Since net present value is 0, so 15% is the true rate of return. These are some of the references that I have used for preparing these slides. Thank you very much. Thank you for watching this video. I hope this will be helpful to you.